that at the end with the. All right, so could you grab the lights again? Thanks, man. But I love that. I love the fact that he used the word. He said something wrong with your arguments. So I mean, he had 3 different approaches, and it's really cool. If you think about it, of course, what's 1 plus 3? 4. So 7 times 13 is 20. You can do the same thing like you can do 7 times 15 equals 42 because 1 plus 5 is 6. So the same arguments he used, you could use to do that, right? Okay. So his arguments were all strong. He had all the pieces. What was wrong with his argument? For example, the last one he did. What was wrong with what he did? 13, 13, 13. These, of course, all represent tens, but he was treating them as if they represented ones. So his premise was, things in this spot you treat as single digits. That was an incorrect premise. It doesn't mean his argument was not strong. He had a solid organization to his argument. It's just that one of the things he used to build his arguments was incorrect, was false. Right? Cool. And now, if you've never seen Abbott and Costello, now you have, and their movies are really cool. And they did like to play around with math. Not all of theirs is about math. Don't get the wrong idea. Every now and again they do something like, do you have 2 tens for a 5? You know,
Who's the first
throw them
one?
off. Sure, here you go, and they go, wait a minute.
Who's the first one?
The first one, the other guy? So they had Abbott and Costello. The other guy was Shemp, was actually one of the later Three Stooges, if any of you guys know the Three Stooges. So if he looked familiar, he was actually from the Three Stooges when Curly took off. Yeah, cool. Okay. So I like to expand your mind in more than just mathematical ways.
On the homework, when you say every third odd, you mean like...
Every third one. Don't be too optimistic.
Oh.
Yep. Because that will make the homework fly by.
Yeah, it was.
But on the top of the homework sheet, I actually should list out like E30 means every third one.
Oh, okay.
So like 3, 6, 9, or wherever I start, just do the 1, 4, 7.
So I did 3, 9, 12, 15.
All right. So I like to do a combination of evens and odds because you've got the odd answers, but you don't have the even ones, and you got to get used to playing without a net, right? So, so we're going to kind of build up what does it mean to be for an argument. What's the right form for it? Those of you who are in the link with Tate, you're going to be talking about the form of a paper, how it relates to the form of a much smaller, like this argument here. You just have to kind of blow it up. Every paragraph could then be a premise, and then your conclusion at the end. And if one of your paragraphs is false, you might have a strong organization, but you have a false conclusion, right? Same kind of idea. So the first thing we got to talk about is the parts of an argument.
What chapter are you in?
This is section 3.1. So just remind you guys, it's a good idea, I think, in general, to have that homework sheet out, so you're not freaked out when I jump around, because we're going to jump around a lot between the chapters. We don't do chapter 2 at all. So one of the most famous ones, little arguments here is Socrates is a man. All men are mortal. Therefore, and we use this symbol here, a little triangle. That symbol represents therefore. And you start to understand why math people made math the way it is. Math people are lazy or frugal with their time, to be more PC. So it's all shorthand, right? All these math symbols are shorthand. They should represent longer words or phrases. So therefore what? What's got to be true? Socrates has got to be mortal. He's going to kick the bucket. He did. He proved it. He kicked the bucket. So Socrates is man. All men are mortal. Therefore Socrates is going to die. Socrates is mortal. Okay, cool. Each of the pieces of the argument is a statement, right? Thankfully, that's what we call it. That actually is the logical name for these. These are all statements.
Are we going to get into trying to identify whether they're deductive, inductive, sound, unsound, cogent?
We're going to get into doing more of the sound, more of the valid, invalid, right? And that would be, does it flow? This is a valid argument. right? Even if I said Socrates is a duck, all ducks eat green cheese. Therefore, Socrates eats green cheese. That would be a valid argument. Again, it relates to how strong, is it a strong argument? Does the organization work? Not is it true or not, just does it flow, right? Okay. So if you have your book, I'm kind of like on page 102. These are all, in fact, to go a little further, these are all simple statements. Because there's only one idea in each one. There's no what's called connectives, which we'll get into in a second. No connect. You can spell, Jeff. There you go. Connectives. There's only one idea in each, right? So connective is exactly what you might think. I always think about that old Schoolhouse Rock, conjunction, junction. Remember that stuff? Nowadays, it's kind of funny how it's come back. It's kind of cool now to have, like in the day, it would just come on in between my cartoons. Like, they're teaching me something. I don't care. It's kind of cool now. So a connective would be like or, and, those kind of things. If, then is a connective. It connects two different statements, two different ideas, at least two. So I could say, for example, the first kind of connective that we can talk about. Let me do it in the same order the book does it. Oh, I'm getting a little ahead of myself, maybe. Yeah. Okay. So connectives like and. I'll come back and talk about negation here in a minute. So I could say Socrates is mortal and he likes green eggs. All right. So he's probably going to die if he eats green eggs, but think about green eggs and ham. Now again, math people, as a math person, I would not be scared, but I wouldn't like all these freaking words and letters. I want to kind of reduce it down to symbols. Because what we're going to eventually do, and I don't want to scare you, because it's not going to be like as hard as it sounds. We're actually going to start doing some analysis, almost math analysis on statements. Whenever I say that, I always feel like I can feel you guys going, what are we going to do? But just to kind of show you, this isn't as hard as you might think. A whole phrase I could replace with a variable now, really, with a symbol. So this whole phrase, I can call this whole phrase, Socrates is mortal, I can call it P. So like the value of P in that sentence is Socrates is mortal. Cool? Not too bad. So like normally in algebra you say you have P squared plus Q squared or whatever, and you say, well, what is Q of P is 7? Oh, the value of P is 7. You plug a 7 in. So I'm saying the value of P is this. The symbol and, I mean the word and is used, we use a symbol like that. Some of you guys might know these symbols here from set notation, like A intersect B, A union C, stuff like that. If you don't freak out, it's okay. But if you do, you see the similarity there. It's basically the same symbol, just we don't like the curve. We want to make it have a point. And it looks like an uppercase A. That's kind of nice because it goes along with and. So I say P and what do you think I'm going to make this?
Q.
Q. Beautiful. So in logic, in algebra you use X and Y, and then we kind of go from there. In logic we start with P and Q, and then we go RST, depending on how many statements I have. Cool? Okay, so far so good. The next thing, and is actually the one that's called it's a name term. The term we use is conjunction, which of course is what I reminded about the conjunction junction. Okay, so that's and. The next major one is or. And for those of you playing at home, I'm on page 105. This is a disjunction. the official name of it, right? And just the same way we just did, if I said, for example, Jeff likes the Celtics, or he is insane. So again, I could call in this situation, I could do the same thing, I could call that P, or would be this. And I like that because it's kind of like you or you, I don't care, just somebody do it, right? So somebody just, so do it, get it done, I don't care. So P or, oops, let me put that, or Q, again. There's only two statements in there, you just have to use P and Q. How are we doing so far? So I'm just trying to show you the shorthand, the terminology, the symbols that we use in logic. Logic is really a marriage of English and math, which really scares people, but some of you guys are in a math-English link, so you shouldn't be as scared. What about the same word, and, or, if, then, I think is it? Yes. If, then. So this symbol makes a ton of sense, thank God. And this is called a conditional statement. I can almost spell condition. There you go. So I could say something like if what? If I cook, then you wash the dishes. Okay? Breaking the chores down. I like it. So if I cook, then you wash the dishes. Now here's the symbol you use. It's kind of cool. This leads to that. Right? If I cook, then you wash the dishes. Right? So here's, I could use, again, how many statements are in here? How many simple statements are in there? Two. 1, 2. So I can call this P, I can call that Q. The symbol that goes in the middle makes total sense here. It's an arrow. If P, then Q. So that symbol means if P, then Q.
If happens again.
Little arrow.
If happens, one happens.
If P happens, then Q must happen. Now let's talk about this for a second, because this is the everything. Okay. Now here's the exactly. Now let's talk about it the other way. If I don't cook, will you wash the dishes?
No, it doesn't.
Okay, let's talk about that, because that's wrong. So let's see why that's wrong. Let's say this. This is, I think everybody kind of gets this when I put it in this way. If your dad says to you, or if your mom or somebody says to you, grandpa, uncle, whatever, they say, if you make an A in your class, in your Math 120 class, then I'm going to buy you a car. Right? Is it impossible that you make a B and they still buy you a car? Why wouldn't he buy you a car? He might just want to buy you a car just because. Oh, you tried hard. I know you tried hard. I'm going to buy you a car. Let me give you another. Does that kind of make sense? Mm-hmm. If you make an A, then I'll buy you a car. If anything else happens, I haven't set any conditions. I can do whatever the hell I want to. Right? Does that